In this video, I will explain you what is nuclear fusion. As the name suggests, it is fusion of two nucleus, right? Two smaller nucleus, they combine or they fuse together to a bigger nucleus. What is the reason? Whenever the size of nucleus is very small, or whenever number of nucleons or mass number of a element is very small, very less, then its binding energy would be less. See, deuterium has got binding energy less than 2 mega electron volt. Tritium has got a value less than 4. See, lithium has got, so I could say that binding energy per nucleon is very less with deuterium, tritium and another smaller nuclei. Okay, how can it go to a case where it has got higher binding energy? By combining with other nuclei and becoming a larger nuclei, they would go to a value somewhere in this range where its binding energy per nucleon would be greater than this. I will give you an example. See, in this example, H11 and H11 combine to form H12. See, this is hydrogen and hydrogen become H12. H12 is deuterium, and this deuterium we know that it has got very less. It is the element that has got least binding energy per nucleon. This is unstable nucleus. This will try to combine with one more unstable nuclei to form a bigger nuclei which has got more stability. So we will see the reaction. H12 will combine with H11 and that will become, now one proton and one proton, if two protons come together inside a nucleus, then it is no more hydrogen. Always an element would be recognized by number of protons inside. So two protons, when they come inside a nucleus, then that is helium, and helium is having comparatively higher binding energy per nucleon. It becomes stable, but still this process will keep on going. So He23 when compared with He24, this has got higher binding energy. So what will happen? Two He23, one He23 and another He23, they would combine and they will become in this way. He24, this has got higher binding energy per nucleon, H11 and H11, and this process will again continue. So in this reaction we know that He24 is the product. So He24 has got comparatively higher binding energy per nucleon. Okay, so this is a stable nucleus. So lesser stable nucleus formed again a unstable nucleus, and this unstable nucleus again combined to get a nucleus which has got higher binding energy but still unstable. See, unstable has converted into one thing which is also unstable, but in this process binding energy per nucleon has moved from a value very less to a better value. So I can say that this will release certain amount of energy. Now again H12 and H12 binding energy per nucleon is lesser here. Again that has become an unstable nucleus, but this unstable nucleus has also got comparatively higher binding energy per nucleon. So again that will release energy in this process, but this is again unstable. So again unstable and unstable, that become He24, and which is comparatively out of H11, H12, H13 and He23, this is a stable nucleus that has got higher binding energy or higher binding energy per nucleon. So this whole process when we put together and add, because this process will happen on the surface of Earth, combination of hydrogen to deuterium and deuterium and hydrogen to helium, He23, and He23 on combination, that will become He24. See, on adding up all this equation we will get a value. See, at each stage here there is a release of energy, here there is a release of energy, here again there is a release of energy. Okay, so in all the process we have a release of energy, and this when we brought down to one equation, that would be in this way, and that is releasing the total energy that has released in each step of this whole process. Okay. Now this is nuclear fusion. In nuclear fusion, two smaller nuclei combine to form a bigger nuclei. Why? Smaller nuclei has got lower binding energy per nucleon, lesser stability. Now higher nucleus is having higher binding energy per nucleon, more stability. Okay, so this is nuclear fusion, and during this process it releases energy. This emitted energy can be used for our purpose, but this energy as of now we are not able to make it on the surface of earth because we are not able to control it. So this is called as, this is the thing which is used inside hydrogen bomb. So now, as of now, no more hydrogen bomb is used. So in the nuclear bomb we know how much disaster it has made. So when the hydrogen bomb is released or when the hydrogen bomb is used, we can say that the impact would be very much higher. I could say that 10 times, 100 times or 1000 times more than, higher than the disaster that is made by nuclear bomb. Okay, so one is fission and one is fusion. Fusion releases tremendous amount of energy, very high amount of energy. Okay, so fusion we are not able to control and use it for the purpose of, you know, getting energy. Like for electrical power plant we are not able to use energy released in nuclear fusion, but in fission we are able to use it. But see, when we are comparing fusion with fission, see, in fusion hydrogen, which is not a vulnerable element, even helium, this is also not a harmful element. So one harmful element become another harmful element, or I could say that this process is neat and clean. Okay, there is no harmful element released. But in the case of fission, uranium-238 is a harmful element. It has got radioactivity. This radioactivity can even, you know, penetrate to our cell and can even change the DNA structure. So the whole character of a person would be changed if we are, you know, exposed with radioactive elements. So radioactivity can create a very higher damage to human and even for the nature. Okay, and one more thing, so how we will handle nuclear waste, we have to, that's a very big process, complicated process. We have to dig a hole which is larger in length so that this nuclear emission would not come to nature or would not affect human being, animals or tree. So anyway, handling the nuclear the product of handling the nuclear waste is very difficult, and this is those nuclear waste are having radioactivity and these are harmful to earth. But here in this case it is very neat and clean because hydrogen become helium, both are neat. Next thing is, it is fuel abundant. What is the meaning of fuel abundant? Hydrogen is present everywhere. We have no scarcity for hydrogen here. So if we are able to do fusion in earth, then we will never face any problem due to the lack of hydrogen. But actually uranium-238 used in 236 or 238 used in nuclear fission is not abundant. Okay, so overuse, even the amount of uranium-238 will go less. Next thing is, this is an efficient process. Efficient process means with an input we are getting very high amount of output, but nuclear fission is not this much efficient as compared, but nuclear fission is efficient as compared to burning a coal or using water at, you know, the potential energy stored in water or any other process. When we are using nuclear fission is effective or efficient, but nuclear fusion is more efficient than nuclear fission. Okay, so these are the comparison, but scientists are working on it to control nuclear fusion so that it can be used for our purposes. Okay, thank you.